So we're going to deal with the other trig functions in this section. And so we've done sine and cosine, and we messed a little bit with tangent. We built a triangle. And so now we're going to look at the other inverse trig functions. So we can go ahead and start with the cosecant, the arc cosecant, of negative root 2. So first of all, cosecant is the reciprocal of sine. And so he'll have the same domain as arcsine does, which means since he's the reciprocal, I'm allowed to only live in quadrants 4 and 1 on the right side of the unit circle. Okay, right side of the unit circle. So where does cosecant have a ratio of negative root 2 on the right side of the unit circle? That's going to be at negative pi over 4. Now, let me find my unit circle. Okay, so I gave you kind of a hint for tangent, which would also be a hint for cotangent, because if tangent is growing, so if this is 0, root 3 over 3, 1, root 3, and undefined, then it's going to be the flip of that for cotangent. So this is 0, this is root 3 over 3, 1, root 3, and undefined. Okay, so for cosecant and secant, basically you can have values of negative 2. Okay, so that would be the reciprocal of negative 1/2 or positive 1/2. So either 2 or negative 2. You can have positive or negative root 2, which will be the reciprocals of your root 2 over 2's. And then these ones go funky. These ones are going to be the reciprocals. The reciprocal of root 3 over 2 is going to be 2 root 3 over 3. 2 root 3 over 3. So those are your values that you're looking for cosecants and secants. So when I say that, I know that this is the reciprocal of root 2 over 2. I know that it's negative, so I'm in quadrant 4 or 2, and this is the reciprocal of sine, so I must be in quadrant 4. So I'm looking for an answer of negative pi over 2. So now we've got, let's do the arc cotangent of negative root 3. Okay, so cotangent is going to have the same, arc cotangent is going to have the same restriction as arc cosine, okay, or the inverse of cosine, which means I'm allowed to live in quadrants 1 and 2, top half of the unit circle. So looking at quadrants 1 and 2, I know that cotangent's going to grow. I know it's negative, so I must be in quadrant 2. So this is going to be 0. This is going to be root 3 over 3. This is 1. And this is negative root 3. So I'm at 5 pi over 6. I don't have to do any addition subtraction because I am within quadrants 1 and 2. I am within quadrants 1 and 2. So what about the arc cosecant of negative 2? So the arc cosecant of negative 2. So first of all, what's his reciprocal? His reciprocal is sine. So I need to be in either quadrants 1 or 4, right side of the unit circle. I know it's negative, so I must be in quadrant 4. And the reciprocal of negative 2 is negative 1/2. So where sine is negative 1/2, cosecant will be negative 2. So that's going to be at negative pi over 6. Okay, so I drop down to pi over 6. I find out that cosine is a negative 1/2. So the sine, oh my gosh, I'm dizzy. Sine is negative 1/2. So cosecant would be negative 2. So what this is saying is, where does cosecant have a ratio of negative 2? It happens at negative pi over 6. All right, so now we're going to build some, well, hang on just a second. I've got the cosecant, the arc cosecant of negative 4. Okay, so again, I need to, and I'm going, because this is not a benchmark ratio, I need to look at that as, I'm going to have to use my calculator. Okay, it's not a benchmark angle, it's not a benchmark ratio, so I'm going to have to involve my calculator. So first of all, remember that the cosecant of an angle equals the ratio, which means the arc cosecant of the ratio equals the angle. Okay, arc cosecant of the ratio equals the angle, which means this is a ratio. Okay, and let me tell you something. Your calculator doesn't have a cosecant button, much less an arc cosecant button. So I better put this in something friendly. Since this is the cosecant of a ratio, I'm going to change that to the reciprocal of the reciprocal. Okay, so flip this. So cosecant and sine are reciprocals, and then flip the ratio. It's going to give you the same value. So grab your calculator, which I do have a button for arc sine. So the arc sine of negative 1/4 is going to be negative 0.2526. So you should recognize it would be in quadrant 4 because it's negative. So I had to drop down basically 1/4 of a radian to get there. So negative 0.25. So that's how you're going to use your calculator to do these. So now let's build a couple triangles. Okay, actually let's not build triangles yet. Why? Because I'm following my notes. All right, so I've got the cosine of the arc sine of 1/2. So what we're going to do is work from the inside out. So this says, where does sine have a ratio of 1/2? Sine is allowed to live on the right side of the unit circle when we're dealing with his inverse, which means I'm in quadrants 1 and 4. This is positive. I'm in quadrant 1. Where does sine have a ratio of 1/2 in quadrant 1? That's going to be at pi over 6. So this entire thing, you're answering it. You're saying that happens at pi over 6. Now address the outside. Okay, what's the cosine of pi over 6? It is √3/2. Okay, so let's do it again. We've got the tangent of the arc cosine of negative √3/2. Okay, so work from the inside out. I'm dealing with an inverse cosine, which means I'm in quadrants 1 and 2. It's negative, so I'm in quadrant 2. Where does cosine have a ratio of negative √3/2 in quadrant 2? That occurs at 5 pi over 6. Okay, so that part turns into, you've answered the statement. Okay, so now I'm going to take the tangent of 5 pi over 6. Tangent is negative in quadrant 2, and tangent grows. So remember, this is going to be 0. This is √3/3. This is 1. This is √3. And this is undefined. So it's going to be negative √3/3. All right, let's do the secant of the arc cosine of 1/2. Okay, so you can do this a couple of different ways. Let me do the long way first. Where does cosine have a ratio of 1/2? Cosine, arc cosine is allowed to live in quadrants 1 and 2. It's positive in quadrant 1, and it has a ratio of 1/2 at pi over 3. Okay, so this whole part just turned into a pi over 3. What is the secant of pi over 3? So the secant is the reciprocal of cosine. So if cosine is 1/2 there, then secant would be 2. Okay, now I can use this in a different way. What I could say is the secant of the arc secant of, not -2, of 2. Okay, the secant of the arc secant of 2. So I flip this to the reciprocal. I flip this to the reciprocal. These two things undo themselves, and my answer is 2. So either way, you get an answer of 2. So let's do the cosecant of the arc tangent of -1. So again, these don't have a relationship. These ones did, so I thought it was kind of cool. These ones don't have a relationship that's very upfront. So where does tangent have a ratio of -1? Tangent lives on the right side of the unit circle, quadrants 1 and 4. Tangent is negative in quadrant 4. So where does tangent have a ratio of -1? In quadrant 4, that's going to happen at negative pi. Oh, I just lied to you. Ooh, I lied. No, it is negative pi over 2. Just kidding. Okay, so it's negative pi over 2. Okay, that is where No, what am I doing? I'm looking at secant. I am so sorry. Start this problem over. Where does tangent have a ratio of -1? In quadrant 4, it's at -pi/4. Like, because sine and cosine have to be the same. Sorry. I had a brain fritz for a second. So what is the cosecant, which is the reciprocal of sine, at -pi/4? Okay, so your over 4s are going to be awfully friendly. So the cosecant at -pi/4 will be negative because your y values are negative, and it's going to be -√2 because sine is √2/2, cosecant is √2. You're in quadrant 4, so it's negative. All right, so now let's do a couple more. This video is going to probably be closer to 20 minutes because we're just going to keep plowing through. All right, so I've got the arc cosine of the sine of 7pi/4. Okay, so arc cosine can't live at 7pi/4. 7pi/4 is in quadrant 4, but I don't care. You want to know why? Because I know what the ratio is there. Okay, I know what that ratio is. Sine at 7pi/4 is going to be a -√2/2. So now to do this part. Where does cosine have a ratio? So I answered this part. Where does cosine have a ratio of -√2/2? Arc cosine can live in quadrants 1 and 2. It's negative in quadrant 2. So this is going to happen at, what angle measure does that happen at? It's going to happen at 3pi/4, which is in quadrant 2. Okay? So let's do another one. I've got the arc cosine of the sine of -11pi/6. So this is a benchmark ratio, or I can get to a benchmark ratio. I'm going to start from standard position and go down and to the left, 11pi/6, which is going to land me at pi/6. Okay, what's the sine of pi/6? These are coterminal. The sine of pi/6 is 1/2. So I've answered that part. Now grab this one. Where does arc cosine have a ratio of 1/2? Sorry, where does cosine have a ratio of 1/2? What is the arc cosine of 1/2? Arc cosine lives in quadrants 1 and 2. This is a positive ratio. You're in quadrant 1. And it has that ratio at pi/3. Okay, so let's take one more step, and then we're going to build some triangles. Okay, we are going to build some triangles. Actually, let's stop there because I'm not going to get this done in the next 7 minutes. So I will pick this up with a second video.